Hello everyone, we are going to solve worksheet number 7, which is from Biocalculus book, and it is about section 3.1, 3.2, which are about derivatives. As the first question, we would find an equation of the tangent line to the parabola y equals 4 over x at a point 2 and negative 2. So we know that in order to write the equation of the tangent line, we are going to find the slope at this point. So m, by definition, is a limit of f of x plus h minus f of x over h when h is approaching 0. So limit, instead of f of x plus h, we would plug in x plus h here instead of x, and we would have 4 over x plus h minus f of x. We know that y is the same as f of x. So 4 over x is here, over h when h is approaching 0. Now, limit of h is here, h is approaching to 0. In order to combine these two fractions, we are going to multiply the first one, the top and the bottom, by x, and the second one, the top and bottom, by x plus h. So for both of them, it will be x multiplied by x plus h as the denominator. And for the numerator, the first one will be 4x, and the second one, by distributing 4, we would have negative 4x and negative 4h. So we can rewrite it as h multiplied by x times x plus h when h is approaching to 0. And in here, since 4x and negative 4x are cancelled out, we would have negative 4 times h as the numerator. Now we can say that we are going to cancel out h and h here. So we would have this equation, this fraction here, equals to limit of negative 4 over x times x plus h when h is approaching to 0. And applying 0, substituting for h, we would have negative 4 over x squared. And using the point that is given to us, we would find this as x equals 2. It will be negative 4 over 4, which means negative 1. So this is the slope that we are going to use to write the equation of the tangent line. Having the slope and the point, and using the formula y minus y sub 1 equals m x minus x sub 1, and with the noticing that this is x sub 1, this is y sub 1. So we would plug here for them y minus, instead of y sub 1, we would write negative 2, m is negative 1, and x minus x sub 1, which is 2. So it will be y plus 2 equals, distributing negative 1 will be negative x plus 2, and by subtracting 2 both sides, we would end up with y equals negative x as the equation of the tangent line here. For question number 2, when we want to find the equation of the tangent line, again, we are going to find the slope. And the slope here is the same as y prime. So by definition, we would have limit of f of x plus h. It means that you are going to replace x plus h here instead of x. So we would have 3 times x plus h power 2 minus x plus h plus 1 minus the given function, which is 3x squared minus x plus 1 over h when h is approaching to 0. Now you can either use the formula or just multiply x plus h by itself, and you would get 3 multiplied by x squared plus 6xh plus 3h squared minus x minus h plus 1. And by distributing -1 here, we would get -3x squared plus x minus 1 all over h when h is approaching to 0. Now, we can cancel 3x squared here, positive and negative. We can cancel out x positive and negative, also 1 positive and negative. So we are left with limit of 6xh plus 3h squared minus h over h when h is approaching to 0. We know that we can factor out h here, and we are left with 6x plus 3h minus 1 over h when h is approaching to 0. Now we can cancel out h and h here, and by applying h approaching to 0 by replacing h by 0, we would get 6x minus 1 as the equation, as the formula for y prime. Now, using the point that is given to us, x equals -2, slope will be 6 multiplied by -2 minus 1, which is -12 minus 1, -13. Now, having this slope, because we know that this one is also slope, and the point that is given to us, we have x as -2, and by plugging in x equals -2 into the formula, we would get 3 multiplied by -2 squared minus -2 plus 1, and the answer will be 15. So we have the point -2 and 15 here. So it will be y minus 15, as we talked about the equation of the line, m, which is -13, times x minus 15. It will be y minus 15 left side, -13x for the right side, and okay, excuse me, this one is not 15. This is 2. So it will be plus 26. Now we would add 15 both sides. Okay, so this one is -2. And here will be -26. We would add 15 both sides. Left side would be y, right side would be -13x minus 11 as the equation of the tangent line. Next question is finding an equation of the tangent line to the graph of y equals g of x at the point x equals 7 if g of 7 is -3 and g prime of 7 is 4. So using g of 7 equals -3 here, we would know that the point is 7 and -3. Also, having g prime of 7 equals 4 means we have the slope here. So putting all these together, we would have y minus y sub 1, which is -3 here, equals m, which is 4, times x minus x value, which is 7. So it will be y plus 3 equals 4x minus 28. Subtracting 3 both sides, we would get y equals 4x minus 31 as the equation of the tangent line. Next part is about observation deck. The upper observation deck of the CN Tower is approximately 447 meters above the ground. Suppose a ball is dropped from a height of 447 meters and ignore air resistance. Part A. What is the velocity after 5 seconds? In order to find the velocity formula, we are going to use the equation of the motion. As you may know, the equation of motion is written as S equals f of t equals 4.9 times t squared. So we are going to use this formula in order to find the formula of velocity. So we know that velocity of the point t is the derivative of the equation of the motion, which is f prime of t here. So it will be limit of rewriting the formula when instead of t we have t of h. So we would have t plus h minus f of t all over h when h is approaching to 0. And we would get, instead of f of t plus h, we would have 4.9 times t plus h squared minus 4.9 t squared over h when h is approaching to 0. Of course, we have limit here. And it will be simplified to, we can factor out 4.9 and then write the equation as t plus h squared. So if we apply this square here, we would get t squared plus 2 times t times h plus h squared. And we have factored out 4.9 here, and we are left with negative t squared over h when h is approaching to 0. Now we can cancel t squared, positive, negative here, and we are going to factor h here. So we would have 4.9 times h multiplied by 2t plus h all over h when h is approaching to 0. So we would see that we can cancel these two h's here, and after applying h equals 0, we are left with 4.9 multiplied by 2t. Altogether, we would have 9.8t. This is the formula for velocity. But the question is, what is the velocity after 5 seconds? Now that we have the formula for velocity, we can apply 5 here. So we plug in 5 and we would get 9.8 multiplied by 5, which is 49 meter per second. For part B, it says, how fast is the ball traveling when it hits the ground? So as we know that the height of this tower is 447 447 meters. So since the observation deck is 447 meters above the ground, the ball would hit the ground at the time, let's say t sub 1. So using the equation of the motion, we would say that S of t sub 1 is 447 meters. And also, using the equation of the motion, this amount here is equal to 4.9 t sub 1 squared equals 447 meters because of the equation of the motion. Putting them equal and dividing by 4.9, we would get t sub 1 squared equals 447 over 4.9, which is approximately for t sub 1 square root of 447 over 4.9, which is approximately 9.5. So it is recommended that you don't find this quotient here and after that using the square root. So since it is going to be a decimal answer, if you divide here and you are going to round it once here, and again after taking square root, you are going to round it again, there can be more amount of error. So it is not recommended to round 2 times. Okay, the velocity of the ball as it hits the ground here is v at the point that we have found here, t sub 1, which will be 9.8 multiplied by this square root here. We talked about not rounding 2 times. And this is approximately 93.60 meters per second. Let's move on to the next question. It is question number 5. The number of bacteria after T hours in a controlled laboratory experiment is written as n equals f of t. For part A, it says, what is the meaning of the derivative f prime of 5? What are its units? So as we write the answer for part A, we are going to say that f prime of 5 is the rate of growth because it is derivative. This is the rate of growth of bacteria population after 5 hours. So what is the unit here? The units here are bacteria per hour because it is given to us per hour. For part B, it is asking that if suppose there is an unlimited amount of space and nutrients for the bacteria, what do you think is larger? F prime of 5 or F prime of 1? F prime of 5 or F prime of 10? If the supply of nutrients is limited, would that affect your conclusion? So with unlimited space and nutrients, F prime is increasing. So F prime is increasing as T increases. So F prime is increasing as T increases. And we can conclude that F prime of 5 is less than F prime of 10 as it will be an increasing function here. But if the supply of nutrients is limited, the growth rate is going to slow down. So when it is limited, it will be slowing down at some points, and gradually it will be disappearing, it will be decreasing, and it is not going to be more than before. So maybe it is not increasing in this case. Let's move on to number 6. Sketch the graph of a function g for which g of 0 and g of 2 and g of 4 is 0. So we would say, using this information here, we have 3 points, 0 and 0, 2 and 0, 4 and 0. Also, we know that g of 0 is 0. Also, we know that g prime of 0 is 1. So if we are going to sketch this graph, we know that we have points 0 and 0, 2 and 0, 4 and 0 here. Other informations, according to the question, says when you have g of 0 equals 0, it means you have the point 0 and 0. Also, you have g prime of 0 equals 1 from here, and g prime of 4 equals 1. It means that we know that derivative is also slope. It means that the slopes here are 1. So we would round off our figure at the points that are between these two numbers. Also, we have g prime of 1 here and g prime of 3 equals to 0. It means that at 1, we have horizontal tangent line. Also at 3, we have horizontal tangent line. But why the first one is at the top of x-axis and the other one is at the bottom of the x-axis? It is related to g prime of 0 equals 1. So when it says g prime of 0 is equal 1, and also we know that g of 0 is 0, we would conclude that we are going to have this kind of graph with slope positive. And for the left part, since limit of x when x is approaching to negative infinity is going to be negative infinity, we know that the graph is going left and down. So the graph is crossing the origin, and it should again cross the x-axis with a slope of negative 2, because we have g prime of 2 equals negative 1. So there is no other way that we would round it off here to have the slope of negative and reach the other point. And again, since at 4, we have the slope of positive 1, we are going to cross the x-axis. And since the limit of g of x when x is approaching to infinity is going to be infinity, the graph is moving up and right. Let's move on to number 3 here. We are going to find f prime and its domain using the definition here and graph f and f prime. Following the definition, we would have f prime of x equals limit of f of x plus h minus f of x over h when h is approaching to 0. So it will be limit of square root of x plus h minus square root of x over h when h is approaching to 0. And now, using conjugates, we are going to multiply the whole fraction here by square root of x plus h plus square root of x, because it will be its conjugate, over the same thing. Now, by multiplying these and using the formula that we had, 8 minus b multiplied by a plus b equals a squared minus b squared, we would get limit of square of the first one, which is x plus h, minus the square of the second one, which is x. And for the denominator, we are going just to rewrite whatever we have here when h is approaching to 0. We see that we can cancel x and x here, and also we can cancel h and h here, because after canceling two x's, we would have h at the top, and h at the numerator and denominator are going to be canceled. And now if you plug in for h, you would have x plus h square root of x when h is approaching 0. So by plugging in for h, you would have 1 over square root of x plus the square root of x. It means 1 over 2 times square root of x. Now, how can we find the domain here? We can use graph or we can use the formula. If we want to find the formula for f, the domain and range, we will have all positive numbers because no negative number can be replaced on the radical, but we accept 0 here. And based on the definition, it will be the positive answers, not included for the 0. And as we have seen before, this is the way that it looks like when you have square root of x. This is f. This is f. And for f prime, since this is the formula for f prime, we would see that the domain is all real numbers, positive ones, but not 0. So it will be 0 and infinity, not included. And for the range, it will be 0 and infinity. And how can we graph this one? Since the graph of f is all increasing, you would have f prime at the top of the page, so over x-axis. And since it is a reciprocal function, it will be looking something like this, as 1 over 2 times a square root of x. Next question is about finding derivative of this quotient here. Again, we would follow the formula of the definition, which says f of x plus h minus f of x all over h when h is approaching to 0. So we will have x minus 1 over x plus 2 minus the function that is given to us, which is, okay, excuse me here. we would have x plus h minus 1 because we are going to write f of x plus h. And for the denominator, it will be x plus h plus 2 minus, for f of x, we have x minus 1 over x plus 2 over h when h is approaching to 0. So we would use LCM here. We know that if we want to combine these two quotients here, we are going to multiply the first one top and bottom by x plus 2, and the second one top and bottom with x plus h plus 2. So we will have limit of, if we do this multiplication here, we would have x plus 2 multiplied by x plus h minus 1 and minus x minus 1 times x plus h plus 2. And those denominators here can be written in the denominator all at once. So we would have h multiplied by x plus h plus 2, also multiplied by x plus 2 when h is approaching to 0. Now we are going to multiply all that we have for the numerator. So let's write the denominator here down. And for the numerator, we are going to have x squared plus x times h minus x plus 2 times x plus 2 times h minus 2 minus x squared plus x minus h times x, and I would write the rest here, plus h minus 2 times x plus 2 with the same denominator. So if we look at them carefully, we would see that these will cancel out, these will cancel out, also x will cancel out, 2x will cancel out, and 2 will cancel out. So we are left with limit of 2h plus h, which is 3h over whatever we have for the denominator. And we know that we can cancel these two here. So we are left with 3 over x plus 2 squared. And this is the formula for f prime of h here. Let's move on to number 9. Number 9 says, figure that is given to us shows a graph of metabolic power P of nu consumed by humans who walk and then run at the speed v. Is P a differentiable function of v? The answer is no, because we have a corner here. So the answer for A is, since graph has corner at the speed a little bit after 2, because if this is 2, it's a little bit after 2. So since we have a corner at, let's say, nu equals like 2.2 meter per second. So it is not differentiable. But it is differentiable at all other points, before this, after this. So this was for part A. And about part B, it says sketch the graph of P prime of nu. So in order to draw the graph, we are going to say that before 2.2, the graph is increasing. So since it is increasing and the slopes that we have here, if you draw some tangent lines here, you would see that the slopes are all positive. So it will be a positive amount for y value and it will be increasing. So something like this. But after 2.2, we have a straight line. It is not a horizontal, not a vertical line. It's a tilt line, but it is straight. So we need to find the slope of this line here. We can pick two typical numbers here. We have 2 over 2. Let's find another one as like 4.4 or any other number that you would like after 2.2. And using the graph, we can guess the points. If it is 4 or if it is 4.4 can be somewhere here. And we would connect it to the vertical axis. And in order to find the slope, we would subtract y values and over x values. So for 4.0, maybe we can find 1500. So subtracting 1500 with the amount that we may have for 2.2, which is somewhere here. So it can be less than 2.2 is somewhere here, and it is less than 1000, maybe 850. Over the difference of x values. So it will be 650 over 2.2, and it will be approximately 295 W over meter per second. And this means, since this is the slope, this means that we would have a straight line if it is starting 0 and this is 1 and this is 2 and a little bit after 2, it will be a line here and the amount of y value here is this slope, 295. Let's move on to question number 10. It says if f of x equals x cubed minus x, and we are going to find f prime, f double prime, and f, which is the derivative number 3 of x. So again, we are going to follow the formula of f prime. It will be limit of x plus h cubed, based on the formula that we have here, minus x plus h, subtracting the f of x itself here, over h when h is approaching 0. So you may remember the formula of x plus h cubed. If not, you can multiply this 3 times to itself. either is fine, and you will have x cubed plus 3x squared h plus 3x h squared plus h cubed minus x minus h minus x cubed plus h, because we would apply that negative here. And we would see that we can cancel x cubed, both of them. We can cancel x, and we are left with limit of 3x squared h plus 3x h squared plus h cubed minus h over h when h is approaching 0. Now we can factor out h here, and we would have 3x squared plus 3x h plus h squared minus 1 over h when h is approaching 0. So we can cancel h and h here, and we would plug in h as 0. So we are left with 3x squared minus 1 here. Now, if we want to find f double prime, it will be limit of, so this is the function that we have here, and we are going to plug in x plus h squared minus 1 minus the original function, which is 3x squared minus 1 all over h when h is approaching to 0. If we apply that square either with a formula or multiplying by itself, you would end up with 3x squared plus 6xh plus 3x squared h squared minus 1 minus 3x squared plus 1 all over h when h is approaching to 0. We would see that we can cancel 3x squared, we can cancel 1 and negative 1, and we would end up with limit. For the remaining terms here, we can factor out h, and we would have 6x plus 3h over h when h is approaching to 0. Then we can cancel these two. We would plug in h for 0, 0 for h, and then 6x is the answer. Next part, let me erase all these that we have here for the first one. Next part, the next derivative is going to be based on the one that we already found here. So when we want to use this one, we are going to have f of x plus h again. So f of x equals limit of 6. Instead of x, we have x plus h minus the function itself over h when h is approaching to 0. We would have limit of 6x plus 6h minus 6x over h when h is approaching 0. We can cancel out these two. We can cancel out h and h. So the answer is just 6. Now it is time to graph all these. For the first one, as we are not going to graph this using mathematical ways here, we are going to use Desmos or any other calculating ways, graphing ways, and we would say that for f, this is the graph of f, which is x cubed minus x. So this is f. Using this graph, as we say that we would have a horizontal line here and here, and between these 2 points, the graph is decreasing. It means that for f prime, these 2 points will be 0. Between these 2 points, the graph is decreasing. It means that the derivative is negative. So we have negative and it is continuous, something like this. Before this one, the graph is increasing. It means that you have positive part. And also after this one, it is also increasing. So you have positive one. Now, if you want to draw the double prime, the second derivative, you would see that for f prime, we have horizontal line here. So it will help us to draw this point, which is the origin, as 0 for next derivative. Before this, the graph is decreasing. It means that you would have negative values, which is under x-axis. And after this, it is increasing, which is positive. Using this graph, we are going to draw third derivative. Graph of second derivative has no horizontal tangent line. We know that for all parts of this line, the tangent line is positive. So we would have slope as a constant, any number that we can see here, but positive. So this is the way that we would draw third derivative. Let's move on to number 11. It says, shown in the graph of population is the graph of population function P of t for yeast cells in a laboratory culture. For part A, graph to derivative. We know that for this graph here, if we draw some tangent lines, they would be all positive. And for here, we are going to have change of concavity here. So following this formula as f, if we want to find derivative of f, we are going to say that at this point, before this one, you see that the slopes of tangent line are always positive, but the y values of p prime, because this is p of t, not f of t. So it is better if I write P here. P and P of prime. So stars relatively small here, and after that keep increasing, reaching at a maximum here at about somewhere between 5 and 10, let's say 6. And then it decreases to 0 because you would see that this part of the graph is going to be almost flat. So after this point, it will be whatever it is going to reach 0. Of course, not always 0, but it is going to reach 0. And before this, it is increasing. So it will be something like this. Let's move on to the next one. Graph f prime below the given graph. So for the first one, if we want to draw f prime, we would see that we have horizontal line here, here, and here. It means that for f prime, we would have 0 at this point, also this point, and this one. Okay, before this one, we would see that the graph is decreasing. So before this point in the graph of f prime, it will be negative. Between these two, the graph is increasing, so it will be positive. We have to draw that here. And between this one and the third one, it is again decreasing. It means that we have negative part. And after this point, it is increasing. Next one, we would start with horizontal tangent lines. We have one here, we have another one here. For these 2 points, we have 0 for f prime. And also here. Between these 2 points, the graph is decreasing. So it means that for f prime, the graph is negative between these 2 points. So it will be something like this. After this point, it is positive because it is increasing. And before this, since it is decreasing, it will be negative. Okay, this was all for worksheet number 7.